All right, 8th grade, we're in the kitchen this morning for part 2 of Investigation 4 on convection, and part 2 is entitled Convection in Water. And so we're in the kitchen today because I need a cold source and I need a heat source for this demonstration. And so it's actually quite challenging. The demonstration is very delicate. If we were to do this in the lab, many of you would be quite frustrated with how it goes down. And so I'm going to do my very best here in the kitchen to demonstrate what's going on today. You're going to want to go ahead and find the document Layering Hot and Cold Water. It's going to be pretty useful for you this morning. And so, you know, yesterday's demonstration and the day before or so, we've a couple days, working with the idea that density is dependent on weight of a material if you have the same volume. And so now, instead of playing with weight and volume, we're simply only going to manipulate the temperature of a sample. And so let me show you what I've got going on here. My son thinks he's a walrus this morning. He's using Cheerios as his big walrus teeth. I've got the famed blue porta potty water here. You can see that it's in an ice bath. And so I am cooling that. In a clear vial, I have a sample of room temperature water. It's been sitting out for a while. And then finally, in a hot water bath, I have some red water that I've simply dyed with food coloring. And so all the samples that we're going to work with this morning, they are only water and food coloring if they are colored. So take a look at the prediction part on the document Layering Hot and Cold Water. And so you need to make a prediction, because here in a minute, what I'm going to try to do is I'm going to try to create a sample of stacked layers in this vial of different colors of water. So I'll have clear water and blue water and red water, and of red being the hot, blue being the cold, clear being the neutral. And so you need to, in the first part of the prediction, draw or somehow create a diagram for how you think I'll be successful in getting those to layer up. Okay, I've only got one shot at this. You can see that the vial of clear room temperature water sitting on the middle of the white cutting board. So I'm going to try to do my very best to get this right the first time. Porta potty water is at a premium. I don't have very much. And so we're going to try real carefully here. I'm going to stick the pipette all the way to the bottom, and I'm going to see if I can create a layer of blue water all the way on the bottom of this container. I hope you're able to see that there. Okay, now that I've got blue, it looks like it's sitting pretty well. I've got blue on the bottom. I'm going to try to take my red water, and I'm going to try to drop it right on the surface at the interface here. And so I hope you can see that the red water is clinging to the top of the, oh, I got a little bit heavy there, but you can see it rise back up for some reason. So we think about density, you know that bodies of something that are less dense will float. And so I hope that you can see we've been able to create a reasonably patriotic vial stack up here. I hope my dish towel's not too dirty. If I set it behind it, you can certainly see that there are layers here. The red is on the top. I've got the blue sitting pretty nicely there on the bottom with the clear in the middle. And so I'm going to let this sit for 5 minutes, set the microwave timer, and we'll see what happens. Well, it's been 5 minutes, and you can see that there are no longer any clear, distinct layers in our vial. It's quite interesting. I think it's really pretty, actually. You can see that the red water has fallen into, it's got these little thread-like strands into the clear water. Maybe it's starting to move into the blue water there, the porta potty water there on the bottom. And so on the document, Layering Hot and Cold Water, why don't you guys take a moment? You're able now to respond to the part about conducting the investigation. So initially, how was I able to successfully layer the water, and then now after 5 minutes have passed, what's going on? What can you observe? There are some analysis questions for you to take a look at there as well. While we're waiting for the 5 minutes on the microwave for our other sample to check out here, I've created another stacked layer. This one did not form as well as the first that I made for you, but you can see there's still some layers in there. But the question becomes now, what happens when I heat this? And so I've got some warm water here. Let me add a little bit more. I've had the French press going this morning. Get some hot water out of here. And so if we heat this sample, what is going to happen to it? And so if I place this container in hot water, we're going to let that go. The goal here, let's check it out. Let's see what happens. It's being heated, and I can certainly see that the colors are shifting a little bit. It's quite interesting. Pull this up, you can see that the red is seems to be sinking into the center and toward the bottom of the container. I can only infer that because we're heating this from the bottom up, that perhaps the blue water might be rising. And so again, this requires you to think about how the particles in a substance behave when there are changes in thermal energy. Do they move faster? Do they move slower? Do they get closer together? Do they move farther apart from one another? How are these things going to affect the density of some material? And even something as simple as water here. And so we have the same material, and yet we're able to manipulate the density of that as well.